G'day guys. A lot of people wanted me to do a tear down of this detector, even though it's pretty brand new. It doesn't have stickers on it, warranty void and all this bizzo. I don't suggest that you pull one of these apart if you own one. Leave it intact because this circuitry and the parts and everything is very specialized, and there's not much that anyone could really do on one of these detectors. So I was going to give it a bit of an overview, and like I say, I'm pretty experienced pulling sensitive electronic equipment apart, so I'm not going to damage it. I know what I'm doing. I'm not going to yank the wrong thing, rip cables or break things, and it's just a reversal of pulling it apart, and it'll go back together nicely. So that's the front panel. The front panel, it's got a rubber gasket on it, bit of Perspex, I think. Yeah, and a Mylar type printed flexible PCB with touch buttons and interface cable. So with that, I'll put that up there on my electronic design book. And yeah, I've actually just compare it with a GPX detector here. This is one that came off the quad bike. It doesn't work no more. It's all fractured. But if you have a look at the parts count on this and the component overlay and all the rest, I mean, it's an old design now, but still pretty much works state of the art. But the amount of the component count on this is astronomical. So that's the GPX, which had a hard time. Actually belonged to the brother of one of Australia's most famous prospectors. I'm not going to say his name, but anyway, here is the detector, and if we have a look at it, it's very neat. It's got a lot of very modern components. A lot of these parts in here, except for the big chunky things, but a lot of the small stuff has only been out for about 12 to 24 months. And it hasn't had all the parts numbers gouged off that has been known to occur in the industry, which makes repair very difficult, and you have to go and nut out what every device is. So in that regard, it's repairable. Not that I see anything that's going to really happen to anything there. I think it's, as far as I can tell by looking, it's a good layout. It's got a lot of switch mode power supplies in there, supplying different rails. I think some of it's 3.3, and have a step up more than likely for the transmit pulse. I haven't measured it, so I don't know. I'm just guessing. But where the important stuff lives on this board, and I was going to take the display out, but I decided not to, because these Mylar ribbons, they are meant to go in and out, but I don't like doing it. The reason being, this one's really tight, and I'm not going to risk it, because I don't want to rip the ribbon in half and then have a problem. So I'll just pick this up very gently and lay it over. No stress. Make sure that little ribbon down there, that's the one that just pushes in. It pulls out, but it's a very tight fit. I don't want to do it. It's very small, and if it does, it's a real disaster. You've got to, what do? You put another display in it. So you could do. Anyway, let's have a good look in here. There's the main brains of it. Let's move this wire there. That's a speaker wire, by the way. So speaker plugs in there on the bottom of the board down there. Just pulls out in line, pop, out it comes. But, you know, I don't really suggest anyone go and do that. But anyway, I'll just straighten that up. I don't want to have any stress whatsoever on that little Goldie Mylar flexible connector. None whatsoever. Anyway, if we have a look there, there is a ARM Cortex processor, MPU, CPU, whatever you want to call it in there. That is a really top-notch device. That is, when it comes to something like that, this is the bee's knees of a processor to use. It has a lot of onboard peripheral stuff. I think it has 3 built-in ADCs. It's got a stack of I/O lines on that. There is, God, I think there's something like, if memory serves me right, there could be something like 160 I/Os on that. And the funniest thing of all, you can actually clock this chip at 480 megahertz. So if you're going to clock these ICs so fast, you can do a lot of sampling very quick and very instantaneously. And the other thing too, when you clock at very high frequencies, you get away from the baseband of where these detectors operate. So you actually, in a way, decrease the noise around the circuitry. You know, there's no way known that the input stage is going to handle anything clocking, you know, probably not even anything clocking over 10 megahertz. But, you know, running these things so fast, it alleviates a lot of problem. You know, you can get an overall rise in background noise, but it's, you know, it's not in the pass band of what signals you're looking for. So unless you're doing microwave work and high frequency RF, I wouldn't worry about it. So that's the main guts of it there, that big square thing. I haven't looked at the other chips, just a lot of general I/O stuff. I think that Cortex processor can drive the LCD directly. I'm not a digital person, I'm an analog person, but I'm pretty sure it can, because I have hunted up on these chips before for another project. But that's very, very nicely put together, good layout, and I will give 10 points. And for the parts not having the numbers ground off. The thing is, the A7 main processor there, if that has been set up in a way, which I guarantee it has, that the code inside that chip cannot be written or read out, should I say, that everything's safe as houses. No one will be able to decode that. These ICs have ways and means that if you try and fiddle it, it will start dumping code and you won't get anything out of it. So yeah, it's basically knockoff proof. These processors are very, very good for security. It's really right up there. Well, there's nothing wrong with the ones in the Minelab either, like that, the H8 Renesas chips, or Hitachi, whatever they were. They're quite good as well. I don't know anyone who has. We know that there was Chinese knockoffs on the Minelabs, and that was from other reasons. It wasn't hacking the ICs or anything like that. So anyway, I'll put that back over. The red and black wire there, that's for backlighting of the display. So I'll just leave it sit there like so for the moment till I line everything up. You have a good look at it. It's got you can see those inductors there for switch modes or voltage conversion. You'll flip him over carefully. Have a look. That's why the back of the box has got that deeper section. It has electrolytic capacitors, they would all be to do with the stabilizing the transmitter. There's a 2.2 microfarad high voltage 630 volt blue polyester cap sitting there. Some resistors, a few chips here and there. It's a good layout. There's your speaker. It's very interesting. I'm going to check this speaker out a little bit more. Someone I was talking to, he said they don't like the sound out of the speaker. Yeah, I'll have to investigate that, why. That's funny, but yeah, it's very compact. It's mainly, you could say probably 90% of this detector is done as per functionality is in that microprocessor. It does a lot of stuff. It's got a lot of stuff in that. Oh, it's got 16 watchdog timers in it and all sorts of things. I remember reading about it when I was looking at something else, and it was just fantastic. So that is the guts of it. So yeah, you can see where things plug in. I did notice it has a provision for, or it has got a microphone on the back of it as well. So it secretly listens to you. No, it doesn't. It's to do with surrounding sound cancellation, as far as I can tell. I haven't even read up on it, so I don't know. I'm just looking at it from a logical perspective that is what it has. The thing is too, the A7 Cortex processor can also do 3 channels of video, and it hasn't got a camera on it. I don't know, but yeah, it hasn't got anything like cellular based or GPS based or anything like that in there. So yeah, where you find your gold safe. Yeah, it's just a functional detector. Now, I don't know what else I can say. All I really want to do is just a quick overview. You can have a look at it. It's not going to vibrate apart. You know, in the field, it's solid. The components are very small. There's nothing there. It's got a lot of mass that's going to vibrate like hell and break off. You know, the only thing that possibly, no, it's not going to. You know, I'm clutching at straws trying to find things that are maybe going to happen in the future, but I really doubt that it is. And yeah, that's the detector. Dave's just rolled up to get his boxes that are here, so he just stuck his head in the door and saw me making a video, so he disappeared. But yeah, I can power it up and have it on the bench and poke and prod and everything else, but I don't really want to just yet. We'll get some age on this detector. We'll do some field testing and we'll see what it goes like out in the goldfields. And that should be happening on the weekend. So yeah, it'll go up and you can check it out. But I like the design of this. I think it's pretty good. There's nothing wrong with it. It looks like a fairly good layout. You can tell that the people who built it know what they're doing. You know, I can just tell because I notice there's guard ring tracks on the back of the board in critical areas. The way they've done earthing or grounding, should I say, and even the board layout, how they got the plane taken away in certain areas for certain reasons, and then very under a lot of other parts. Yeah, we won't go too much into that because it's probably, a lot of it is tricks of the trade in design. And yeah, you can see it that there's ground plane there and there's areas that haven't. Like you see tracks that are just away from everything. And yeah, that's all to do with noise pickup and high-speed digital data lines and so forth. They're, like I said, tricks of the trade. You got to know what you're doing. If you did this and you didn't know what you're doing, you just, you know, used to making analog electronics, well, knowing analog, you probably pull it off. But if you're a a digital guy who probably mucked around with things clocking at a few hundred kilohertz, you'd probably make a mess of it. So you've got to have a really good understanding of analog and a very good understanding of high-speed digital techniques making stuff like this. And to my eye, and in my opinion, they have done a good job. This is a good detector. It's very, very good indeed. So that's 15 minutes of teardown on one of these. And now I'm going to go and reassemble it. And the reason being is I just don't like something like this. It's basically brand new, and it's in bits just staying there. So I will put it back together, and then we'll run some, I might run some tests on the bench. I'll just do some static tests on it and see what we can make it do. Because it works only on mono coils, we have some figure 8 coils I can run it on in the workshop, and we'll just get some sensitivity tests and just look at the functions on the front menu. So that will be the next video, because I'll do that tonight. And then in the morning, we'll see if we can run around with it and see what we can find out in the goldfields. Anyway, that is the Algo Force E1500 or E1500. Anyway, catches.